Hello and welcome back. Today we're going to add the Dear Imgui library to our engine. Now if you're not familiar, Dear Imgui is a framework that allows us to define an immediate mode graphical user interface. That's what Imgui stands for. And this really just is a really easy way to get up and running with a UI for our engine. And it's what I used in the showcase video at the very beginning of the series. So I'm here on the Dear Imgui GitHub page and I want the docking branch because this allows us to dock things left and right and have a very nice sort of layout for our editor. So docking branch, you can now pull this code. You can do this, you can download a zip as well, whatever works best for you. The point is that we're taking the latest from the docking branch and downloading it so we can add it to our project. And here it is. So I've just downloaded it to a programming libraries ImguiWindow folder, and here's all the files for ImguiWindow. So we're going to drag some of these files into our Hippo folder. Now what I want is for these to be compiled in with the engine. So I'm going to go to Hippo, go to include, and I'll add a new folder here for external. So we have our external folder at the root level, that's for like SDL and GLAD and those sort of base things. And this external folder will be for frameworks that Hippo leverages that we're also exposing to the client. So in this case, we'll start with ImguiWindow. And yes, it's called Dear Imgui, but I'm just going to call it ImguiWindow because it's easier that way. And then we'll just pull in all these files. So all of these, we want the license as well. Copy that in there. And now we also want a couple more things. So we're going to look into backends. Now ImguiWindow supports tons of backends, like any backend you could think of. For us, we are using OpenGL3 and we're using SDL. So we're going to grab these four files here, and paste them in here as well. And now if we go back here, let's go to MISC and CPP. And these two allow us to use the standard library along with Dear Imgui. So we definitely want to pull these in. And then lastly, we'll want the debuggers folder. And the debuggers folder, if you look into it, it has these sort of, the NatVis is what we care about for Visual Studio. It basically makes it prettier to look at in the inspector when you're looking at these ImguiWindow data structures and that sort of thing. And that'll be in the README as well. Okay, so we've pulled in everything we want for ImguiWindow, so let's go back and open our Premix5 Lua. So here's our Premix5.lua, and we talked about the externals. These are the externals that are at the root level. For the externals that we just added, these are going to be compiled in with the engine. So we're going to want them, they're just going to be built with the engine. So we're going to include them in our files here. Now again, anything that's under files is going to get compiled into hippo.lib. So we're compiling everything in. So if we look at the kind of files we just added, external ImguiWindow, we have headers and CPPs being under the include folder. That's fine, we don't have to split them up. And then we have the NatVis that we care about, right? So here we've got under include, which is where the externals live. We also, and again, the double star is recursive find, so any header under the include folder and any subfolders underneath that. So now we'll also want to add CPPs because that's where the ImguiWindow CPP files live. And then maybe at the bottom here, we'll just also add that NatVis. So it's under I don't want to leave it under include, like we could add our own NatVis for anything, so we'll just do a recursive .natvis here. I've never actually tried to add a .gdb file to like properly see internal data structure that has some better defined way of interpreting that data in like the locals view. So I don't know if maybe like if you're on Linux, maybe you just add that **.gdb for the other one. For now, I'll just do NatVis since I am primarily working on Visual Studio. It's also not a required thing. It's just easier to debug when you're looking at it. So now I should be able to go back to Hippo, and let's just open CLI.bat so we can Genesis. And now everything's been added, so if I go here, I'll reload. Okay, so now that we've included Dear Imgui, I need to actually set it up, initialize it, run its sort of initialize and shutdown code, just like we would with SDL in terms of getting that initialized. Now I'm going to keep that under, we'll just call it ImguiWindow. I don't want to call it just ImguiWindow.h because ImguiWindow has an ImguiWindow.h and I just want to avoid any confusion there. So we'll add a Hippo ImguiWindow.h to the core and ImguiWindow.cpp as well. So similar to our existing window.h, we're going to have these sorts of create, shutdown, HandleEvent, all that sort of stuff, because the way ImguiWindow works is it sort of piggybacks off of your existing backend, right? Again, for us it's SDL. So it's going to use SDL and it's going to handle events so that it can render itself and expose the widgets that we can use and all that sort of stuff. Let's go back to ImguiWindow.h and we'll start again with our namespace. somewhere in Hippo core. We'll have a class ImguiWindow. Public, private. So we'll have an ImguiWindow that does nothing. ImguiWindow that does nothing. We'll have a void create. Void shutdown. And then maybe a void like HandleSDLEvent, because it does need to get passed in some SDL events, so SDL_event reference E. And then it's going to have a BeginRender and an EndRender as well, because it has a similar concept of beginning to render ImGui and to end the ImGui frame. Now SDLEvent, it doesn't know what that is, so struct SDLEvent. It's better. Actually, let me just make sure it's actually not a struct, it's a typedef union. So I'll take this. Yep, that should do it. So we actually don't need a private. Everything's just going to be public. And now let's switch to CPP. So include Hippo, core, ImguiWindow, namespace Hippo core. And now we can define our create. So ImguiWindow create. Now, to start making calls to ImGui, we need to include our external ImGui, ImguiH. Now we'll also need our backend files as well, so ImGui_impl_SDL and ImGui_impl_OpenGL3. Okay, so now we can actually start making calls, and the first thing we have to do is call this macro called ImGui_checkVersion. And then we have to initialize ImGui with a call to ImguiCreateContext. Context. Now, similar to OpenGL, where everything is sort of, it's just a context, you have an OpenGL context, and then you make state changes to that context. It's the exact same thing here. ImGui, you create this context, and then you can make state changes to ImGui. And now we get into the backend setup, right? So we call these ImGui_impl_SDL2_init for OpenGL. That's what ours is. I don't know why IntelliSense wasn't finding it, but it is init for OpenGL because we're using SDL2 with OpenGL. So now we have to pass in the SDL window and the void star to the SDLGL context. So actually we need our window here. So include hippo/engine.h, and we can just pull out our window. So auto reference window equals engine instance get window. So I think our window already has a get SDL window. Maybe it doesn't. Let me see. Get window. Yep, window. Okay, it doesn't. So we need to expose these two. So we'll need to expose SDL window. So let's just do it here. SDL_window star get SDL window. Let's just return on window from here. And then same thing, SDL_GL context, which is already a void star, right? That's what it's SDL is doing. Get GL context. Return on GL context. Okay, perfect. And now we'll just pass those along. So get SDL window and then window.get GL context. Okay, so we've initialized it from the SDL side. Now we need to initialize it from the OpenGL side. ImGui impl OpenGL3 _init. And it takes a string representing the GLSL version. So you know our shaders. If we just go to our main.cpp now, where we have our shader, we have this line, right? So we need to tell ImGui which version to use for the shaders. So I'm basically just going to copy this. I don't think it needs core, it just needs the version. So I'll just copy this, and I'll just paste it here. That's all it wants. Okay, because ImGui is using shaders internally, so it needs to know what version of GLSL to use. So we pass this in like this. Okay, that's it for the initialize. So for the shutdown, we sort of do the same in reverse order. So ImGui_impl OpenGL3_shutdown. Just call that method. And ImGui_impl SDL2_shutdown. And then we call ImGui : destroy context. And we will destroy the context we created up here. That's how you clean up ImGui. Now we had HandleSDLEvent it takes in an SDLEvent reference E, and we just pass that along to ImguiWindow. So ImguiWindow underscore impl SDL2 underscore process event, and pass it in. Now it takes a pointer to the event, and we're pulling it in by a reference because that's what we have on the engine side. So we just get a reference to E, and then we just have our begin and end. So ImguiWindow BeginRender and ImguiWindow EndRender. For BeginRender, we're just going to call ImguiWindow underscore impl OpenGL3 underscore new frame, and then ImguiWindow underscore impl SDL2 underscore new frame. And we pass in that window again, so just the same one we passed in up here. So let's go engine instance GetWindow.getSDLWindow. And then on the ImguiWindow side, ImguiWindow new frame. Okay? And now for EndRender, ImguiWindow : render. This is where it actually triggers all its render calls that you've accumulated over this frame and actually executes them. And then because we're using an OpenGL backend, we have to call ImguiWindow underscore impl OpenGL3 render draw data. And we'll pass in ImguiWindow get draw data. And that's all there is to it. So there's not a lot there, and honestly a lot of this just comes from the docs. ImguiWindow has great documentation that tells you how to set everything up, so that's just where I got all this from. But now we have an ImguiWindow that can set all this stuff up, and now somebody needs to own this ImguiWindow. For us, it's going to be our window class. So window.h needs to know about ImguiWindow. And it's going to have an ImguiWindow and ImguiWindow. So let's just go ahead and use it. So here in our create, once we've set up GLAD and everything, we have OpenGL available, we can just call ImguiWindow.create. Now in terms of the rendering of ImguiWindow, I'm not going to do it across our begin and end render because I don't want ImguiWindow rendering sort of while we're rendering. Especially if we're trying to render, let's say we're rendering our entire game onto a texture and then we want that texture to show up in ImguiWindow. We need to finish rendering that texture first, right? Now it doesn't mean we have to swap the window yet. We actually don't want to do this until the very end. So just in our Windows end render, now is where ImguiWindow will do its rendering. So ImguiWindow.beginRender. And then we'll just call ImguiWindow.endRender. Now in between here is where we can actually make some real ImguiWindow calls. So let's include ImguiWindow real quick. And ImguiWindow does bring a demo window, so ImguiWindow : show demo window, and this will show just a demo window of what ImguiWindow can do. And again, we had to embed ImguiWindow into window because we need to make ImguiWindow end its render before we swap our buffers, right? Otherwise we'll never see anything. Now let's just try and run it and see where we're at, because that should be everything. Looks like there is an error with this SDL. Yep, so ImguiWindow assumes you just have a path to SDL, which we don't. We have SDL2/SDL. So that should be good. Let's try that. Another place here. SDL2/SDL Vulkan. And moment of truth. There it is. There's Dear Imgui. And you can see it's rendering perfectly on its own. We haven't done anything. We just say, hey, I'm using SDL, I'm using OpenGL, and it just knows how to render itself. And Dear Imgui says hello. Now, we can't render outside of this current box, even if I stretch it, because we don't have, our viewport is not being resized properly. But ImguiWindow, again, it handles everything on its own, so it can do that. And if we just take a look at some of the examples here, let's open up, for example, a log. So there's our log. We can add 5 debug entries. So you can imagine all the logging that we're currently doing to the command prompt, we could actually do to an ImguiWindow window and just see it all here. Right, very cool. Let's close that off. Let's go to Tools, Metrics, and Debugger. So there's our FPS. We're running at 144, which is v-synced with my monitor. That's awesome. Some tools. So Item Picker, sure. Oh, look at that. So now we can see which items we're hovering over. But I think the point is, triggered a breakpoint there, no problem. But I think the point is very clear. Like, ImguiWindow is super powerful, and you saw how easy it was to get integrated and set up. So now we can start using it to do stuff. So here's our viewports. You can see if I drag this around, it knows where its viewports are. So that's very interesting. Some of the widgets that ImguiWindow supports, for example, basic widgets like a button. You can click the button, checkbox, our radio buttons, different colored buttons. You can hold to repeat. Hover over me, I'm a tooltip, or me, I'm a fancy tooltip. So in order to support something like this for our editor, we're going to not show the demo window, although the demo window is extremely useful just in terms of learning how ImguiWindow works. And like, I'll just show you. If we go to ImguiWindow_demo.cpp, let's just search for a button. So here I can just call ImguiWindow : small button, and it will do stuff, right? Let's look for more buttons. Log buttons. Here's a proper button. So if button clicked ++. This is what I'm talking about immediate mode, right? Here we're saying if ImguiWindow : button, this is defining that you're drawing a button with the text box, with the texting button, and it will return whether or not it's clicked. It's all immediate mode. You're not defining anything in a class. You're not storing widgets locally, anything like that. It's all done in line like this. And that makes it really easy to quickly build up some nice UIs. So let's go back to our window for a sec. Now we were calling something in between here. Now really what we want is our app to be able to do that. So you can imagine that the first step is to add an additional method, ImguiRender. We'll need our engine.h to expose our app, because I don't think we return it at all, so yeah. Let's do it up top. So inline app star get app, return map. And now window.cpp, instead of calling show demo window, we'll call engine instance.getApp. And maybe our app, maybe it'll return a reference, because I don't want the caller to call delete on it. So we'll return a reference to it. So I'm just dereferencing it there. And now getApp.ImguiRender. And what's wrong? I don't have engine. I do have engine. Oh, I need app from here. So it's because it's defined in the CPP for engine. There we go. So now in my main.cpp, I can just add a void ImguiRender override. And if I include ImguiWindow here, I can now start calling ImguiWindow. So just to show it, ImguiWindow : show demo window. That should have the exact same effect. And in our window.cpp, I think because we're not making any ImguiWindow calls, we don't have to include this here anymore. So let's switch back to main.cpp and just run that. Should be the exact same. And it is. It's way over here because ImguiWindow actually remembers where you leave windows, and it will restore them where they were. This is what's going to help us in terms of defining a docking layout, and we can just keep it that way. And the way it does that is by adding a folder, a file. If we just go to HippoEditor, this ImguiWindow.ini. So when I run the application from Visual Studio, it's running from this folder. So you can see ImguiWindow created this ImguiWindow.ini that just has this sort of concept of like the Dear Imgui Demo window. That's the position, that's the size, it's not collapsed, right? The other windows I opened, it's all tracked here. So if I was to open them again, it knows exactly where to put them and what size to put them at. So that's how that works. If I was to run ImguiWindow from a different location without this ImguiWindow.ini, everything would sort of go back to its default. So that's how we sort of keep that state and track it. But now if we want to do something a little more custom, let's have a way to modify this offset. So we modify this X and Y offset with the keyboard and the mouse and the D-pad on the joystick. Why can't we also add a way to modify it from ImguiWindow? So it's these two, X key offset and Y key offset. Now these are floats that live within editor. They're here. So in order to create our window, you call ImguiWindow : begin. And you pass in the name of the window, so we'll call it rect pause, let's say. And you have to match ImguiWindow begins with ImguiWindow ends. And then inside of these two calls is when we can actually start rendering things. Now begin does return a bool. It'll return a bool, and it probably tells you somewhere here. Yeah, returns false to indicate that the window is collapsed or fully clipped. So you may early out and omit submitting anything to the window. You have to call end for each begin, regardless of its return value. So just to show what the impact of that is, for example, between the begin and end, I'll do a hippo trace test. And as you can imagine, as I'm running this, we should see a new window called rectpos, and it's printing test every time. Right? I can close this window and it's still printing test. So if instead of doing that, I wrap this in an if, again, I call end regardless, but now test should only be printed if the window is actually being rendered. Right? And right now it's closed, and you see, I guess it prints once for some reason. That's probably an ImguiWindow thing. But if I open and close, yeah, you can see that it's now only printing when it's open. And that's important because if we're doing some heavy stuff in here, we can actually not do it if the window is not even being rendered. Now for us, we do want to render something, and let's just expose X key and Y key offset so we can modify it. The way you do that is with Imgui, drag float. And do float, float 2, 3, or 4. Let's do a float 2. So we pass in a label. The name will be rectpos, and then you pass in an array of 2 floats. Now, because our floats are separate, let's actually just do float 1, and here it takes a pointer to it, so we'll pass in a reference to our X key offset. So this will be rectpos X key offset. The speed, so how quickly does it move in terms of while you're dragging it, let's make it small, so 0.1f. I don't know if that's small enough, we'll see. And we have to pass in a min and a max. Do we have to pass them in? No, their default is 0 and 0, which means there won't be a min and there won't be a max. So let's just try this and see what that does. Now, you can see I'm passing in X key offset as a reference to it, right? It's taking in a pointer to it, which means that as I'm dragging this widget, I'm actually modifying the value of X key offset. And we'll see that in the next update here when we set the offset uniform. So let's open this up, and now we see this thing. rectpos X, and it's a sort of thing in the middle with 0, and I can drag it. And you can see as I drag it, the color is changing. Now this is not my mouse, like I know my mouse would only change it a little bit, but as I'm dragging this, you can see that I'm actually moving that X offset. Now if I use my keyboard, you can see the numbers actually change on Imgui as well. The reason that works is because every time we're coming into ImguiRender, we're taking the actual value, the current value of that thing, and we're populating drag float with that in there. So now let's do the same for Y. Y key offset. Maybe we'll make it a little smaller here so that we can. Okay, and you can see it again. It's very intuitive. It just knows that I have to be able to scroll now, so I do. And then let's change the X, and let's change the Y. There we go. So now you can see how easy it was to just have something that very easily hooks into our existing data and makes changes. I did mention that you can see that the mouse is still affecting the game while it's sort of over top of ImguiWindow. We can actually prevent that from happening. So you can see right now, as I move from left to right, our color is changing, even though I'm hovering over an ImguiWindow. What we can do is actually ask if Imgui is currently handling a mouse or a keyboard, and if it is, we won't handle it. And Imgui exposes this with just with that internal sort of state. So we can just add some methods here. Let's say bool want capture mouse, and it's called want capture mouse because that's what the underlying method is called. So I'll just keep it the same. Want capture mouse, want capture keyboard. Okay, so now let's just make these method implementations. And we're just going to return Imgui getIO.wantCaptureMouse. Same with here with keyboard. And then on our window.cpp, which is where we update our input, we only want to update our input if Imgui isn't currently taking them, right? So if not ImguiWindow.wantCaptureMouse. So if Imgui does not want the mouse, I can update the mouse. Same here, if not ImguiWindow window.want_capture_keyboard, then I can update the keyboard. And so now if we run that again, we should see that the colors are changing properly, but as soon as I go over the window, it's no longer updating our game. And then as soon as I go off to the end, you'll see it snap to the new color because it's sort of jumping from this very low position to this very high position. But at least now we can ensure that as we're clicking through and typing things in ImguiWindow, we're not affecting the game underneath. And that's going to be very important because I don't want me dragging this around to like click the UI in our game or something like that. Now there is another thing I wanted to clean up. Window.h. Its create method is currently just hard coding all this stuff in here, right? What if I wanted a bigger window? What if I wanted different flags? What if I didn't want it to be resizable, right? I want these things to be passed in, but I don't want to have to pass them into this method because it means this is going to be really large, and as I want to expose more data, I'm going to need to keep redefining this sort of API. So you fix that by having a properties structure. So we'll just call it struct WindowProperties. And now we can define everything we want to pass into create, right? And create will end up taking in a WindowProperties reference props. This actually should be able to be const because it's not going to be changed. So what were we defining? Like a title, the XY width height flags. So that's already a bunch of stuff. So string for title, int XY width height, and int flags. Now we'll need to string. I think we also could pass in a clear color because we can define a clear color. The minimum size, we can do that as well. Again, this is being hard coded, so int wmin and hmin. The flags, let's say our clear color, we need to think in these 4 floats right now. So float, clear color red, clear color green, clear color blue, clear color alpha. Actually, I think alpha will always be, we probably want alpha to always be 1. So let's just do red, green, and blue, RGB. And then we'll have a window properties constructor. And the reason I do that is because for X and Y, for example, where we might want to use something that SDL provides, I can't do that here in the header because I don't want to include SDL here. Otherwise, the client app will need to know about it. So we'll just have this window properties constructor. And here we can just set everything up. So title can just be Hippo app. It'll be easier just to retype it. So X equals centered, Y equals centered. Width, let's just say equal to 1920, height by 1080. Let's say width min can be 320, height min can be 180. And then the flags will just take in this. And for the clear color, let's just grab our render manager. It should have the clear color that I like. Yeah, this one. Let's take this. So clear color red equals that. Clear color green equals this. Clear color blue equals this. Okay, so now our window properties has sensible defaults. Const window properties reference props. And now instead of hard coding all of these things, we can just say props.title.cster, I think. Yeah. Props.x, props.y, props.width, props.height, props.flags. And then for window minimum size, props.wmin, props.hmin, and we can set the clear color right here. So engine instance get render manager dot set clear color, props.cc red, props.cc green, props.cc blue, and 1.f. So now again, we need a way for our app to be able to override these things, right? So it'll have to be before initialize. So we'll have a new method, app.h. Let's have a, we now need to know about windows, so include Hippo window, Hippo core window. So we'll do a virtual, and we can just return a WindowProperties object. Say set, or maybe GetWindowProperties. And this will have to be core. And we can just say return core WindowProperties. Semicolon. So just return the default, and then we can override it on the app side. Okay, so now if we go to engine.cpp, before we get started, just one quick thing here, where we had our mouse and keyboard, and we said we didn't need joystick because we didn't initialize, but we actually shut down. We need to call shutdown. And we weren't doing that before, so we weren't properly cleaning up. So maybe just after we shut down the app, because we initialize input, then the app, so we'll shut down the app, then we'll shut down input. So input, joystick, shutdown. Okay, good. Now we could say window properties props equals and app dash arrow get window properties. It will either be, and this is core, and this will either be the default that app is returning, or it'll be the one that the client app overwrote. And then we'll just pass it in, props. So if we run this now, we haven't done anything on the client app side. We should see Hippo app, and it should be full screen. And you can see that it is full screen. I guess I don't see a title because it's full screen, but this will say it right here, Hippo app. Okay, now I don't have, I guess when you match the size of your monitor, it probably just does a full like borderless full screen style thing. So anyways, I'll just close that out, and that's good. So now on the main.cpp, we can core window properties, get window properties, and we'll just create a core window properties object. We'll call it props. Props.width equals, let's go back to our 800, props.height equals 600, and maybe we'll say props.title equals HippoEditor. Return props. Okay. And you can see that it works perfectly. So it's a smaller size, HippoEditor, and it's working. So now one last thing before we wrap up today, I do want to show the docking and a couple other things. So you can see the window's pretty square. I can drag it from the title bar, but I can also drag it by just clicking on the background here. So if I'm not dragging a widget, I'm dragging the window. I'm not a fan of that. I find myself dragging things all the time, especially with docking enabled. So I'm going to make it so that I have to drag on the title bar. I can't drag from here. And I'll enable docking. So let's start with ImguiWindow.h. And just like we did properties for window properties, let's do the same for an ImGui one. So struct ImguiWindow.Properties. And we don't need much, we'll just probably have a couple bools. So bool, let's say move from title bar only equals true. And I can say equals true because I'm not accessing any SDL stuff from here. Bool, let's say is docking enabled equals false. Let's start it with false, and then there's another thing called Viewports. We can set that up as well, so we can drag Imgui windows outside of the primary window and they'll still work. So bool is viewport enabled. That's what it's called on the Imgui side. Again, we'll start it with false, but this one will default to true because I really don't like that thing. And again, we have to pass that in the create method. So pass in a const ImguiWindow.Properties reference called props. On the CPP side, we'll use it. So we're just going to map into that Imgui context. So after we create the context, we can pull out this Imgui IO, and we'll have a reference to it. We'll call it IO equals Imgui get IO. Okay, and that drag from title thing is within IO. So IO dot move from title bar only. Yeah, it's config windows move from title bar only equals props dot move from title bar only. And then we can also enable and disable our viewport and docking. So if props dot is docking enabled, IO dot config flags or equals Imgui config flags underscore underscore docking enabled. And then we'll do the same for viewport. So if is viewport enabled, and this will be viewports enable. Now the viewports is a little more intricate than just turning it on. Because we have an OpenGL context for our own window, the way Imgui does it is they create their own OpenGL context for their own windows. Now, if we're pulling an Imgui window outside of our primary window, it is now its own window with SDL. So it needs its own context for OpenGL. So when we end the render, here we end the render for our window and our context. And now we need to also do the same for the viewports. So we just get that ImguiIO reference IO equals Imgui : get IO. And now we can just check if io.config flags and, so bitwise and Imgui config flags viewports enable. So this will be a non-zero value if that's on. And now we can do this context switching thing. So we'll need the window, so auto reference window equals engine instance.getWindow. Imgui update platform windows and ImguiRender platform Windows default. So this is how it's handling its own windows, just like we have our own SDL window. And now we have to switch that OpenGL context back to ours, but when it's done, so that we can start rendering back to our own OpenGL context. So SDL underscore GL underscore make current. So we'll pass in window.get SDL window and window.get GL context here. And I don't have SDL here, so this is the first time we're using it. Include SDL2/SDL.h. Okay, so just a little bit more work for the viewports, but that should be all we need. So now, again, how do we pass in this ImguiWindow's properties into ImguiWindow, especially if we're just passing stuff into window.h? Well, we can just have, we already include ImguiWindow, so let's have an ImguiWindowProperties ImguiProps here. So we'll pass it in, and then create, when we create that, we will also pass in props.ImguiProps. And now we have sensible defaults, so we should be good to run this. And what the only change we'll see now is we can only drag Imgui windows from the title bar. And so I'm going to try dragging it from down here, and you can see the drag does not work. But our mouse stuff is still working, and then if I drag from the title bar, I can drag properly. Now, let's go one at a time. Main.cpp, and let's just say props.ImguiProps.is viewport enabled equals true. So just all I have to do on the client side is turn that to true, and now I can drag this Imgui window outside, and you can sort of, I don't know if you saw it there, it sort of snapped, and now it's its own window. It lives free floating. I can move this around, I can move this around, I can still resize this, oops. You can see it actually shows up as 3 separate windows because this is actually its own SDL window now. Imgui is handling all that for us, and now I can resize this thing. So you can imagine I could have like the game here and then a couple other panels maybe for more interesting data over here, and you can see it all still works properly. I'm still modifying everything I need to modify. And I can put it back by dragging it over top, and now it's part of this again, and now you can see it can still work. Now I haven't tested viewports in a non-Windows environment, so maybe I'll keep it like this and I'll just test it on the Mac side. Now we can say, let's try is docking enabled equals true, and we actually shouldn't see any difference right now. And the reason we don't is because there's nothing to dock with, right? You can dock Imgui with itself. So there's no other thing here to dock this rect pause into. So if I now change this, and let's make these 2 separate windows, rect pause X and rect pause Y. And yeah, I did forget to call Imgui end. So if we try that now, You see, because the names changed, ImguiWindow didn't know what we preferred, so it put them back at the default. And now we should be able to drag this on top of this, and you see we have this little overlay. And so if I drop it at the bottom, now I've docked rect pos y under rect pos x. Now they're one and the same, and I can sort of change that spacing between them, and you can see they both still work just fine, but now they're docked within each other. And I can pull it out and dock it the other way. So maybe I'll dock it in the middle, and now I have tabs, rect y x, or at y and x. I can rearrange the tabs, right, x and y. I can also put it to the right side, right? Docking works just exactly as you'd expect. Now what we can't do right now is dock this to the window, right? Like, what if I want this to always be sort of the left side of the window and this to fill up the whole space? And that's really what it's going to give us that editor style feel to it. We actually can do that very easily. And this is actually brand new. This is very recently added. We can just add a line before we start rendering our ImguiWindow stuff. ImguiWindow : dock space over viewport. And we'll pass in ImguiWindow's getMain viewport. It wasn't this easy when I was building the engine originally, but now it is, and you can see I have this sort of space, and now I can dock things to the window. And anything that doesn't have any space or anything docked in it will be this gray color. Now you can see our windows actually, when I dock them, you can see it actually has this sort of semi-transparent background, and you can actually see our rect is rendered behind it. You should be able to see these color changes here as I make them. So there's the blue, there's the green, blue, green, right? And I can sort of resize this stuff as I see fit. And this is really just an artifact of the fact that ImguiWindow's windows are transparent in nature. So when I dock them, they are transparent, and the gray is not being rendered under this transparency. So you can see here, you might wonder, well, I can sort of see the gray, like it's much darker. That's because I'm transparent, but there's dark gray behind me, right? But if I do this, that gray isn't being rendered there, and now it's just somewhat transparent against the viewport that HippoEditor is rendering to. Now obviously this is not going to fly, we can't do this. So what I'm going to do is I'll leave it like this, and then in the next video we're going to figure out how to render our entire scene into a texture that we can then pass to ImguiWindow. So I should be able to have what I'm rendering for the game show up in a texture within ImguiWindow. So we'll leave that for next time, but for now this is pretty sweet. You can already see this coming together, right? I could have my inspector panel, my entities, like, if you saw in that first video where I sort of showed off that engine showcase, that's sort of how this was built. It's just with docking and some fancy panels. So that'll be it for today. Thank you for watching, and next time we'll talk about frame buffers so we can actually render everything to a texture and then render that texture within ImguiWindow. Thanks for watching.